All right, so today we're going to be focusing on related rates, and I'm going to go through a problem. Really, it's a few problems from the textbook, but it's really one problem worked all the way through that they put on page 200, problems 9 through 12. So it says that a 5-meter ladder is sliding down a wall. The variable h is the height of the ladder's top at time t, and x is the distance from the wall to the ladder's bottom. Okay, so let's go ahead and put that out there. I will use blue to represent the ladder. So when I go ahead and put that down, I know that this is 5 meters. Something that's important to note is that the length of the ladder is not increasing or decreasing. The length of the ladder is set. It's not one of those ladders that's extending out. So it is set at 5 meters. And it is, the top of the ladder is sliding down the wall, so the bottom of the ladder is sliding away from the wall along the floor. Okay, so we have that the length of the ladder is 5 meters. They also give us that this distance is h, so the distance up the wall is h, and then the distance away from the wall right here is what they call x. Now, I am going to put down a little right angle mark there because where the wall meets the floor should be 90 degrees. That should be a right angle. And so this is our situation. And so the next thing that they give us is assume that the bottom slides away from the wall at a rate of 0.8 meters per second. So we are assuming that the bottom right here is sliding away from the wall at 0.8 meters per second. Okay, well, like we talked about, if this distance right here is x, that represents the distance from the bottom of the ladder to the wall, and the ladder is sliding, the bottom of the ladder is sliding away from the wall, then that value of x is increasing. So therefore dx dt is going to be positive. So this is what I'm going to call dx dt, but I always need to check whether dx dt is going to be positive or negative. I do see that it's going to be positive here because x is increasing, and like we learned, even with curve sketching, where the derivative is positive, that means that the original is increasing, and so x is the original, and so dx dt is going to be positive because x is increasing. Okay, so I have that. What else do they give me for number 9? They say find the velocity of the top of the ladder at t equals 2 seconds if the bottom is 1.5 meters from the wall at t equals 0. So this starts out, the bottom of the ladder starts out when t is equal to 0. I have that x is equal to 1.5 meters. They're asking for what happens when t is equal to 2. Well, if the bottom of the ladder is sliding away from the wall at 0.8 meters per second, after 2 seconds, that's going to be 1.6 meters, in addition to the 1.5 meters that it started at. So I guess here I should say x of 0 equals 1.5 meters, but x of 2, so when the time is 2, is going to be 1.5 meters plus the 0.8 meters per second times the 2 seconds, right? And so the seconds cancel out, and then that just gives us 1.6 plus 1.5, which is 3.1. So that's going to be 3.1 meters. All right? So at t equals 2, I have that the distance away from the wall, that the bottom of the ladder is 3.1 meters. So that did not require any calculus other than understanding what it means for the bottom of the ladder sliding away from the wall, how we called that dx dt. Okay, so let's go on to number 10. It says, suppose that the top of the ladder is sliding down the wall at a rate of 1.2 meters per second. So now the top of the ladder is sliding down the wall at 1.2 meters per second. Okay, So what that tells me is that that's going to be related to this variable h. Well, if the top of the ladder is sliding down the wall, then I see that h is decreasing. If h is decreasing, then that means that dh dt must be negative. So this I'm going to call negative 1.2 meters per second, and that's what I'm going to call dh dt. Okay? So again, because h is decreasing, I know that dh dt must be negative. They gave me a rate at which the top of the ladder is sliding down the wall, but what I always go back to is how does that affect the variable that it is pertaining to? So in this case, h. Well, h is decreasing, therefore dh dt must be negative. Okay? And then what they also give me is calculate dx dt when h is equal to 3 meters. So this was given so that I could calculate for number 9 the fact that that would have been 3.1 meters. I'm going to erase that because now we're given new information about dh dt, and they want me to calculate dx dt. So let's go ahead and do that. So this was for the earlier problem. So again, it says h is 3 meters. So h is equal to 3 meters. Well, if I have that h is equal to 3 meters, and I have that the ladder is 5 meters, and the fact that I have a right triangle formed here, I know that x must be equal to 4 meters at this particular time. So at this time, I know the distance of x, I know the distance of h, I know what the length of the ladder is, and I know what dh dt is, and the big question is, what they're asking for is, what is dx dt? So dx dt is what? That's my big unknown. So in order to relate rates, I need to first relate variables. And how I'm going to do that is I'm going to say that x squared plus h squared equals 5 squared. So x squared plus h squared equals 25. Okay? So that's how I start. Now, let me differentiate with respect to time. So when I do that, I show that by just saying ddt of that is equal to ddt of that. And now I'm differentiating with respect to time. So what that means is the derivative of x squared with respect to time is 2x dx dt. And the derivative of h squared with respect to time is 2h dh dt. And the derivative of a constant is just going to be 0. And now I plug in all of the information that I know. Well, I know that x is 4 meters, so this is 2 times 4 meters times dx dt, which that's my big unknown that I'm going to solve for, plus 2 times h, well the h is 3 meters, times dh dt. Well, I was given that the top of the ladder slides down the wall at 1.2 meters per second, so therefore I was able to determine that dh dt is negative 1.2 meters per second. So I'm going to put that down right here, negative 1.2 meters per second. And that equals 0. Well, now I only have one unknown quantity, and that's dx dt. So that's the main variable that I'm solving for. So when I do this, I have that 8 meters times dx dt, and then this is going to be minus, so let me go ahead and do this. That's 6 times 1.2 is 7.2, but then it's negative. That's where the minus comes from, so minus 7.2 meters squared per second equals 0. I'm going to move this over, right? 7.2 meters squared per second. So I get 8 meters times dx dt equals 7.2 meters squared per second. I divide by 8 meters. So I'm left with dx dt is equal to, so 7.2 divided by 8 is 0.9. The meters squared divided by meters, one of those is going to cancel out, and I just have meters per second. Now, one thing that I want to note here is that dx dt is positive. I just found that dx dt is positive. I always go back and verify that that makes sense. So what I mean by that is the fact that we have defined x as the distance from the wall to the bottom of the ladder, we can see that x is increasing, so it does make sense that dx dt is going to be positive. If I were to get a negative number here, when I know that the bottom of the ladder would be sliding away from the wall, I would know that I did something wrong. Maybe I forgot this negative or something. But the fact that dx dt is positive makes sense. So that was problem number 10. Then it says, for problem number 11, which is another problem, right? Using the same beginning situation. It says, suppose that h of 0 is equal to 4, and the top slides down the wall at a rate of 1.2 meters per second. Calculate x and dx dt at t equals 2. Okay, so if I had, again, similar situation, wall, what do I call this? Floor. And again, I have that this is my ladder, but maybe it's like that now, so it's more upright. And I have that h of 0 is equal to 4. So again, when t equals 0, h of 0 is equal to 4. So that's what I'm going to call, again, this is h, this is x, and that is still 5 meters. So now I have that h of 0 is equal to 4, but they asked us to calculate x and dx dt when t is equal to 2. Okay, and they still give us that this value right there is going to be, so the rate that the ladder sliding down the wall, the top of the ladder sliding down the wall, is still going to be 1.2 meters per second. So this 1.2 meters per second is still, the negative of that is going to be my dh dt, again, because h is decreasing, so dh dt has to be negative. So when t is equal to 2, h of 2 is equal to, well, I could calculate, I know that at 0, that height is 4, but because the ladder is sliding down the wall at 1.2 meters per second, after 2 seconds, it would have traveled down, the top of the ladder travels down the wall at, it travels down 2.4 meters, right? And so this is going to be 4 minus 2.4, right? And that's going to be meters, which is 1.6 meters, okay? So that's my h at this particular time. Again, we have a right angle there. And so the first thing that they ask me to do is calculate x. Well, this is just by using the Pythagorean theorem. So I have that, x squared plus 1.6 squared equals 5 squared. So x squared plus whatever that is equals 25. I could do that over here, 1.6 times 1.6. 6 with a 3, 6, that's a 9, and 16, so that's 6, 15, so 256. And I have that that's going to be 2.56. So now I'm going to subtract 2.56 from both, and that leaves me with x squared equals 22.44. And so when I take the square root of both sides, I get that x is equal to plus or minus, but of course it's going to be the positive here. And of course I don't have a calculator. All right, so we're going to do the square root of 22.44 to get 4.73708 something, right? So that is my x of 2 when t is equal to 2. Okay? Now, in my calculator, I'm going to store that as, let's just call it alpha A. So that's now stored in my calculator that I can reference that later. So now that I have that, okay, that x is equal to this 4.737 dot dot dot, right? I'm looking for dx dt. Dx dt is the rate that the bottom of the ladder is sliding away from the wall at this particular moment when the height is only going to be, so let me show you with another color, when the height's only going to be 1.6 meters, it might be something like that, where the height's only 1.6 meters, but the distance from the bottom of the ladder to the wall is 4.737 meters, right? So that's what I'm looking for, so I go back to my Pythagorean theorem. X squared plus plus h squared equals 5 squared. I've already done this before, right, in the previous problem, so I don't need to do it again. I know that this is going to be 2x dx dt plus 2h dh dt equals 0. Now, one thing I didn't mention last time, but I'm going to say now, is if I wanted to factor out a 2 and divide both sides by 2, you can see that that's not going to have any effect on this equation, right? So I factor out a 2, now I divide both sides by 2, and I'm just going to be left with this. So let's go ahead and start with just that. And now I'm plugging in all of my known information, and again, solving for my unknown. So when x is equal to that 4.7 value, so 4.737087713 meters, times dx dt, again, that's my unknown, plus h, well, h is 1.6 meters, times dh dt, well, again, dh dt is this negative 1.2 meters per second. Oops. And that equals 0 from this equation right there. So then I would multiply those two, add them to that side, and then divide by this. So really I'm going to get the dx dt is equal to whatever that happens to be, 1.6 times 1.2. It's going to be positive because I moved it over there. That's going to be square meters per second divided by this value, meters. That meters is going to cancel out with one of those guys. And now let me go ahead and plug this into my calculator. I'm going to show you I have 1.6 times 1.2, and then I'm going to divide that by alpha A because I have that stored in my calculator as A, and I get 0.405312 whatever. So 0.405 meters per second. And again, I put an approximately 0.405 because I did round or truncate to 3 digits to the right of the decimal point, which is what the AP exam wants. But again, does that make sense that dx dt is positive? Well, yeah, it does, because x represents the distance from the wall to the base of the ladder. So as the ladder is sliding down the wall, this base is getting further away, and x is increasing. Because x is increasing, dx dt is going to be positive. So that makes sense to us. And I'm going to stop there. Oh, actually, so that was number 11. So number 12 says, what is the relationship between h and x at the moment when the top and bottom of the ladder move at the same speed? We'll talk about that one in class. I think this is enough to kind of get you going, that you could go back and reference to make sure that you understand this. So we've done a couple different problems with the same scenario, same situation. So I hope that's helpful.